Tesla may try to keep secrets, but the keen eyes of fans and enthusiasts always find something intriguing. During a recent video from the company's design studio, one particular scene caught attention. In the background, discreetly covered, was a mysterious vehicle. The shape, size, and even the way it was positioned raised suspicions. It didn't take long for the internet to start speculating. Could this be the first glimpse of the highly anticipated Tesla Model Q? The shadow of this model appeared next to the Model Y, allowing for a comparison that revealed interesting details and raised even more questions. The first thing that stood out was its size. The covered silhouette suggested a vehicle significantly smaller than the Model Y, around 15% more compact. This places the model in the urban crossover category, a highly competitive segment that continues to attract more consumers. If this assumption is correct, it means that Tesla is finally entering the compact electric vehicle market with a model that could compete directly with big names like the Volkswagen ID.3 and Hyundai Kona electric. But size alone isn't the only clue. Other details in the video reinforce this theory. Even with the intentional covering, some design characteristics were noticeable. The roofline, for example, appeared slightly lower than that of the Model Y, while still maintaining the elevated stance typical of crossovers. This design choice could indicate that Tesla is aiming for a balance between aerodynamics and interior space, creating a vehicle that is efficient without sacrificing comfort. Additionally, the way the car was positioned within the design studio suggests that it is still in the refinement stage, which makes sense given that Tesla has yet to make an official announcement. If there's one thing Tesla excels at, besides making innovative electric vehicles, it's building mystery around its launches. And with the Model Q, it's no different. Now that the vehicle has been spotted in the design studio, the next big question is, what are its exact dimensions, and how will it be positioned in the market? Comparisons with other Tesla models and competitors already give us some important hints about what to expect from this new addition to the lineup. The first thing that stands out when analyzing the covered silhouette of the Model Q is its size. The vehicle is estimated to be around 4 meters in length and 1.8 meters in width, placing it in the compact crossover category. This means it will be smaller than the Model Y, which measures about 4.75 meters in length and slightly taller than the Model 3, while still maintaining the aerodynamic efficiency Tesla prioritizes. The size reduction is a strategic move to target a market that Tesla has yet to fully explore, the affordable electric vehicle segment. The vehicle's height also suggests that Tesla is targeting drivers looking for a versatile car for urban use. The Model Q's body appears to be about 100 millimeters lower than the Model Y, but still maintains approximately 50 millimeters more elevation than the Model 3. This balance could indicate that Tesla is trying to combine the practicality of a crossover with the aerodynamic efficiency of a sedan. If this assumption proves to be true, the Model Q could provide an enjoyable driving experience for both city commuters and those looking for a bit more space and height for longer trips. Another interesting detail observed in the design studio footage is the ground clearance. The gap between the car and the floor suggests a clearance of around 170 millimeters, placing it firmly in the urban crossover category. For comparison, the Model 3 has a ground clearance of 140 millimeters, while the Model Y is closer to 180 millimeters. This reinforces the idea that the Model Q will be designed primarily for urban use, while still maintaining enough elevation to handle different terrains and offer a more comfortable driving position. These proportions put the Model Q in direct competition with vehicles like the Volkswagen ID.3 and Hyundai Kona electric, two compact electric vehicles that have already gained traction in the market. However, if Tesla follows its track record of delivering cutting-edge technology and above-average efficiency, the Model Q could pose a major challenge for competitors. After all, Tesla has already proven that it knows how to maximize interior space utilization and optimize aerodynamic efficiency to achieve greater range with smaller battery packs. But not everything is certain. While size estimates seem quite plausible based on visual comparisons, there is still room for surprises. Tesla may have introduced new design concepts to further optimize interior space without significantly increasing external dimensions. Additionally, the vehicle structure may feature lighter materials to compensate for its smaller size, ensuring that the car retains the feeling of robustness and safety that consumers expect. If Tesla is truly planning to launch the Model Q on a large scale, this raises another essential question. Where and how will this car be produced? In recent years, the company has heavily invested in expanding its factories worldwide, and the decision of where to manufacture a compact and affordable model is not something that happens by chance. With the confirmation of a $5 billion investment in Tesla's Gigafactory in Mexico, all indications point to this facility being the epicenter of the Model Q's production. The choice of Mexico for production was no coincidence. Besides its proximity to the United States, which remains Tesla's largest market, the country offers lower production costs than American factories. This allows Tesla to manufacture more affordable vehicles without compromising its profit margins. Additionally, the Mexican factory is being prepared to handle an impressive production volume of up to 500,000 units per year. If Tesla truly aims to make the Model Q one of its best-selling cars, another crucial factor to consider is that Tesla has been exploring ways to reduce production time and increase assembly line efficiency. Initially, many expected the Model Q to be the first car to debut the new unboxed architecture, a revolutionary concept designed to drastically simplify the manufacturing process. However, new reports suggest that to accelerate the launch timeline, Tesla may have decided to build the Model Q on the existing Model 3 and Model Y platform. This strategic shift could be a smart move to get the car to market as quickly as possible. Reusing the Model 3/Y platform has several clear advantages. First, it allows Tesla to leverage its existing production infrastructure, avoiding the need to build new assembly lines from scratch. This can significantly reduce development time and costs. Furthermore, Tesla already has extensive experience with this platform, ensuring a high level of reliability and energy efficiency, which is crucial for a vehicle that needs to be competitive in both price and performance. However, this does not mean that the Model Q will simply be a smaller Model 3. While some engineering elements may be shared with existing models, it is expected to introduce significant changes to better suit the compact car market. The design may be optimized to offer more interior space within a smaller footprint, while lightweight materials could be prioritized to further enhance energy efficiency. Additionally, Tesla may integrate new production technologies, such as the extensive use of gigapress casted parts, a method already being tested in the Model Y. The big mystery that remains is when Tesla plans to officially announce the Model Q, considering that the company has already begun preparing its assembly lines, and that supplier leaks point to an initial production phase around mid-2025. An official announcement in the coming months seems likely. Historically, Tesla enjoys making a major impact with its product reveals, so a Cybertruck-style or Model 3-style launch event could be on the horizon. If there's one factor that defines the success of an electric car, beyond design and production, it's the battery technology. In the case of the Tesla Model Q, the company seems to be taking a strategic approach to balance cost, efficiency, and range. This is a crucial aspect, as the Model Q is expected to be Tesla's most affordable option, and finding the right combination of battery and performance could be the key to ensuring its success in the market. Tesla has already confirmed that the Model Q will use LFP, lithium iron phosphate, batteries in its entry-level version, a logical choice for a budget-friendly EV. This battery type may not offer the same energy density as NCA, nickel cobalt aluminum, cells, which are used in Tesla's premium models, but it has a major advantage. Production costs up to 50% lower. This means Tesla can reduce the car's final price without significantly compromising range. Additionally, LFP batteries are known for their longevity, allowing for a higher number of charging cycles without significant degradation. The estimated specifications for the Model Q indicate that the base version will feature a 53 kilowatt-hour battery, capable of delivering a range of approximately 500 kilometers, 310 miles, under the WLTP cycle. This places it ahead of direct competitors like the Chevrolet Bolt and Hyundai Kona Electric, which have ranges between 420 and 460 kilometers. For those seeking more performance and all-wheel drive, an AWD variant equipped with a 75 kilowatt-hour battery will be offered. However, due to the added weight of the dual-motor setup, range is expected to be slightly lower, around 460 kilometers, 285 miles. Another interesting factor about Tesla's choice of LFP batteries is their superior thermal resistance. Unlike NCA batteries, which can pose overheating risks under extreme conditions, LFP cells withstand higher temperatures more safely. This means that the Model Q could be an excellent option for hot climates, where battery degradation is a common concern. Moreover, this type of battery allows users to regularly charge up to 100% of capacity without experiencing accelerated degradation, something that is not recommended for models using NCA batteries. Beyond battery chemistry, Tesla has been working on new technologies to optimize the Model Q's energy efficiency. Reports indicate that the car may adopt an advanced thermal management system, similar to the one used in the Model Y, which keeps the battery temperature within the optimal range to improve efficiency. This means that, despite being a more affordable car, the Model Q could inherit some of the innovations that have ensured the high energy efficiency of Tesla's more expensive models. Another factor that could directly impact range is the car's aerodynamic coefficient. Estimates suggest that the Model Q will have a drag coefficient of just 0.23, making it more aerodynamic than many competitors in the same category. For comparison, the Model 3 has a coefficient of 0.25, while the Volkswagen ID.3 is around 0.27. This aerodynamic advantage means that the Model Q will require less energy to move, maximizing battery efficiency and ensuring more kilometers per charge. If the Model Q's range is already impressive, its charging speed promises to be an even more interesting competitive edge. After all, an affordable electric car needs to offer not only good range, but also practical charging times for everyday use. And based on available information, Tesla is making a strong effort to ensure that the Model Q provides a superior charging experience compared to its direct competitors. The first major advantage of the Model Q in this regard is its compatibility with Tesla's V3 supercharger network. These chargers can deliver up to 250 kilowatts of power, allowing the Model Q to charge from 10% to 80% in approximately 20 to 25 minutes. This time is already significantly shorter than that of direct competitors, such as the Chevrolet Bolt, which takes about 30 minutes to recover just 160 kilometers of range, or the Nissan Leaf, which may require up to 45 minutes for a similar charge. For those used to refueling at gas stations, the time difference is still noticeable. But for an electric car in this price range, this level of charging efficiency is a major breakthrough. However, what could truly give the Model Q an edge over rivals is its potential compatibility with Tesla's upcoming V4 superchargers. While there's no official confirmation yet, leaks suggest that V4 chargers will be capable of delivering up to 350 kilowatts of power, further reducing charging times. If the Model Q supports this technology, it could theoretically charge from 10% to 80% in just 15 to 18 minutes, an impressive time for a compact and affordable vehicle. This would make charging a Model Q as fast as a quick stop for coffee and a snack on the road. Another interesting aspect is home charging. Not everyone has access to an ultra-fast charging network daily, so home charging efficiency is also a crucial factor. In the case of the Model Q, estimates indicate that it will be able to recover 30 to 40 kilometers of range per hour when charged at a Level 2 station, which typically operates at 7.7 kilowatts. This means that a full charge could be completed overnight in about 8 hours, which is more than enough for drivers who park their cars in the garage after a day's work. Beyond speed, another technical detail could make a huge difference: the possibility of bidirectional charging. This means that the Model Q would not only be able to charge, but also return energy to a home or even the electrical grid, depending on the available infrastructure. This technology, known as V2G, vehicle-to-grid, is already being tested by some automakers and could allow Model Q owners to use the car as a backup battery for emergencies or even to lower electricity bills by storing energy during off-peak hours and using it when rates are higher. One of the standout aspects in Model Q projections is its acceleration. Even though it is a compact car positioned as Tesla's entry-level model, the rear-wheel drive, RWD, version is expected to be able to accelerate from 0 to 100 kilometers per hour in approximately 6 to 7 seconds. This means that even the base version will offer performance similar to the BMW i3 and will even outperform competitors like the Nissan Leaf, which does the same sprint in 7.4 seconds. Meanwhile, the all-wheel drive AWD variant could be even faster, with estimates suggesting a time below 5 seconds, making it comparable to premium models from other brands. Beyond acceleration, another factor that could make the Model Q a more dynamic and enjoyable car to drive is its reduced weight. Preliminary information suggests that the base version will weigh around 1,170 kilograms, representing a 30% reduction compared to the Model 3, which weighs approximately 1,612 kilograms. This weight reduction is due to the use of lighter materials in the body structure and a design optimized for efficiency. With less mass to move, the car will have more agile handling in corners and even better energy efficiency. Aerodynamics will also play a crucial role in this performance. With an estimated drag coefficient of 0.23, the Model Q could become one of the most aerodynamic cars in its category, outperforming the Volkswagen ID.3 and even the Model 3 in this aspect. A lower coefficient means less air resistance, which not only improves energy efficiency, but also contributes to a smoother and quieter driving experience. This is a key detail for a car designed for urban use and short trips, where efficiency is a top priority. Another factor that could make the Model Q one of the most fun-to-drive compact EVs is its weight distribution and low center of gravity. Like all Tesla models, it will have its battery positioned in the floor, improving stability and reducing the risk of rollovers during aggressive maneuvers. The rear-wheel drive, RWD, version will also ensure a more balanced and predictable handling, while the all-wheel drive, AWD, version will provide better traction in adverse conditions, such as wet roads or uneven terrain. Steering response is also expected to be one of the Model Q's highlights. Tesla has consistently invested in precise and responsive steering systems, and there is no reason to believe this new model will be any different. With a light yet direct steering wheel and a suspension system tuned for comfort without sacrificing sportiness, the Model Q could surprise even those accustomed to more expensive electric models. This balance between comfort and performance could be a decisive factor in attracting drivers who are still hesitant to transition to a compact EV. Speaking of comfort, another important factor will be sound insulation. A common complaint about smaller electric cars is that without a combustion engine noise, road and wind noise become more noticeable. However, if Tesla follows the standards set by its current models, the Model Q is expected to feature efficient insulation, reducing external noise and making the driving experience even more pleasant, especially at higher speeds.